Next, we're going to look at testing the individual significance or significance of individual coefficients. In the previous video, we looked at taking all the slope coefficients as a group and seeing whether the null hypothesis that all of them are equal to 0, alternative being at least one is different from 0. Now we're going to look at the individual slope coefficients, and we set up a hypothesis that that particular slope coefficient is 0 against that particular coefficient is not 0. Okay, so we'll have one hypothesis for each slope coefficient. Now we use the t statistic to do the test, and we take the slope coefficient estimate and divide it by the standard error of the slope coefficient. And the critical value for t table for comparison is t alpha over 2, and the degrees of freedom comes from SSE. Okay, remember that is the SSE degrees of freedom. And the critical value can be obtained using the t.inv.2t. Since this is a two-tailed test, we simply supply the alpha value, and Excel will do an alpha over 2 to find the t and then the degrees of freedom. Then we can do p-value. In Excel, the function is t.dis.2t. In ABS, the absolute value of the t, because sometimes t value can be negative, sometimes positive. So we need to make sure that we supply the ABS value, okay, and the degrees of freedom, and so on. Okay, so let's go to the Excel file and demonstrate this. Okay, testing for individual coefficient. Okay, so we have one for each x variable. So first one, beta sub 1 equal to 0 versus beta sub 1 not equal to 0. And then the second, the third, and the fourth. Now alpha will assume 5%, and the degrees of freedom is from SSE. Okay, here SSE degrees of freedom. Okay. Now we have the estimated slope coefficient and the corresponding standard error from the Linest function results. Okay. The only thing is we have to go backwards here. See, that's b sub 0. So we start from here. Okay. And then if you copy that formula down, you get the standard error. See, remember the second row is the standard error of the slope coefficient. Okay. So this is E12. So next one will be going this way, D12, and then C12, and then B12. So these are the slope coefficients. Now if you take that and copy them down one, so the next row is your standard error. So the T then is the slope coefficient divided by the standard error. We copy that, so we have the T, observed T in each of those cases. Okay. Now T table value, okay, there is only one table value, so that will be T dot INV dot 2T, okay, alpha, and the degrees of freedom. So that's our T table value. Now conclusion here, so we can set up a formula for this conclusion, and that will be, okay, if the absolute value of the observed T, if it is greater than the T table value, okay, then we reject. Otherwise, we do not reject. Okay. So you'll now compare the absolute value of this with that T. Okay. So for that, we need to make sure that that T B97 is absolute referenced. So all of them are rejected now. So p-value will be t dot this dot 2t, okay, and the absolute value of the t, comma, degrees of freedom, and that degrees of freedom should be absolute referenced. Okay, so now we'll make that into a percentage and copy. Okay, so you have the p-values. So again, we can do an if function for the conclusion. So if the p-value is less than alpha, and alpha should be absolute referenced, then you reject. Otherwise, do not reject. Of course, the conclusion will be identical. So one is using the table value, the other is using the p-value.